So now let's talk a little bit about independent events. Events E and F are independent events if the probability of F given E is the probability of F, or the probability of E given F is the probability of E. Essentially what this is saying is in either case the given part doesn't make a bit of difference. So if what was given makes no difference to the probability, then you have things being independent events. So let's take a look at our table that we had before. Are the events cashing a check and making a deposit independent events? So what we need to do is we need to check to see if the probability of cashing a check, given that we made a deposit, is the exact same thing as the probability of cashing a check. And we could also, by the way, switch this around. The probability of cashing a check, given that you made a deposit, so let's see, the people that made a deposit, that was 70, and we want to find the people of those, the 50 that cashed a check, so that's 50/70ths, which is about 0.71. The probability of cashing a check, well, that was the 80 out of a total of 110. When we divide that out, we get 0.73. Since these things are not equal, that means the events are not independent. In other words, they're interrelated. One thing depends on the other. So what's nice about independent events, if you can find them, is that the probability of E intersected with F is simply the probability of E times the probability of F. And the reason for that is, remember what our definition was for probability of E intersected with F. That was the same as P of E times P of F given E, and if this given part makes no difference because it's independent, then it just becomes P of E times P of F. Now a really good example of this is flipping coins. When flipping coins, one flip is not affected by the previous flip. So flipping a head on the first flip is independent of flipping a head on the second flip. So what would be the probability of flipping two heads in a row? So we're asking for the probability of heads on first and heads on the second. And because these are independent events, that's just going to be the probability of heads on first times heads on second. So 1/2 times 1/2, which is simply 1/4. Makes things really easy to do. Other situations that are like this is if you're playing roulette. Sometimes you'll see people who are playing roulette where you're spinning a wheel and you're betting on, say, for instance, whether the wheel comes up red or black or no color. And what will happen is you'll see them have red, 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 red on a number of the spins, and they'll think the more reds that I see, the more likely the next one is to be black. Well, those are independent events. One spin is not affected by the next spin on roulette wheel, so that means that they have nothing to do with each other. So assuming that if I get 15 reds in a row, it's more likely that the next one would be black, that would not be a good thing to do because they are totally independent events.